Imagine you're building an AI assistant for your company. You have millions of database records, thousands of PDFs, customer emails, logs, product catalogs, and internal documentation. Wouldn't the easiest solution be to simply give all of that information to the language model? After all, the more information it has, the better the answers should be, right? Surprisingly, that's almost the worst thing you could do. Today, let's understand why modern AI systems almost never send their entire database to an LLM. The first problem is the context window. Think of it as the model's working memory during a conversation. Every document, every table, every email, and every prompt consumes tokens. Even today's largest models have limits. A typical enterprise database contains millions or even billions of records. Simply put, the database is dramatically larger than anything the model can process in a single request. It's like trying to fit an entire library onto one desk. Let's imagine the context window wasn't a limitation. Every time you ask a simple question like, how many customers renewed last month, the system would need to send your entire database to the model. That means transmitting enormous amounts of data, paying for every token processed, and waiting much longer for every response. Suddenly, a 1-second answer becomes a 30-second answer, and every request becomes significantly more expensive. The more unnecessary information you include, the slower and costlier the system becomes. Here's the part that surprises most people. More information doesn't always produce better answers. Imagine asking someone to find one sentence inside a 1,000-page book, while they're forced to keep every page open at the same time. Important information becomes buried among irrelevant details. Modern language models face a similar challenge. The more unrelated context you include, the harder it becomes to focus on what actually matters. This phenomenon is often called the needle in a haystack problem. Instead of sending everything to the model, modern AI systems do something much smarter. They search first. The database stays exactly where it is. A retrieval system searches through millions of records and finds only the handful of documents that are actually relevant to your question. Those selected pieces of information become the context that is sent to the language model. Instead of reading everything, the model reads only what matters. This dramatically reduces cost, improves speed, and often increases accuracy. If you've watched our previous episodes on Cursor or Notebook LM, you've already seen this pattern. Cursor doesn't send your entire code base to the language model. Notebook LM doesn't send every page of every PDF. Both systems first retrieve the most relevant information before asking the model to reason over it. This architecture is called Retrieval-Augmented Generation, or RH. Retrieval isn't just an optimization. It's what makes modern AI systems practical at enterprise scale. Let's step back and look at the complete picture. Giving an LLM your entire database sounds simple, but breaks down because of context limits, cost, latency, and information overload. Modern AI systems solve these problems by retrieving only the information that matters before the model starts reasoning. If you remember only one thing from this video, remember this. AI doesn't scale by reading everything. It scales by finding the right information first. That's the architectural pattern you'll see behind almost every production AI system today. Hope you enjoyed the sketch. We'll see you in the next one.